All right, so now that we've talked about statements, connectives, quantifiers, and we've talked about truth tables, we've talked about what each of the connectives means in a lot of detail and how to make truth tables for each of them. So now that we've done all of that, we're ready to talk about arguments. And an argument is just a series of statements, right? So we put a bunch of statements together and we get an argument. So an argument is a series of statements called premises, followed by a single statement called the conclusion. So premises is the plural. One statement would be a premise, right? So you have a single premise and a group of premises, right? Anyway, so an argument is a series of statements called premises followed by a single statement called the conclusion. An argument is valid if whenever all the premises are true, then the conclusion must also be true. Okay? So here's an example of an argument. If Mahala passed the bar exam, then she is qualified to practice law. Mahala passed the bar exam. Therefore, Mahala is qualified to practice law. Right? That's an argument. In this argument, statements 1 and 2 are the premises, and statement 3 is the conclusion. And this happens to be a valid argument, right? So if statement 1 is true, right? If it's true that passing the bar exam qualifies you to practice law, and if it's also true that Mahala passed the bar exam, then it follows that Mahala is qualified to practice law, right? That's a valid argument. Now here's an example of an invalid argument. If I have the new calling plan, then I can text my friends for free. I can text my friends for free. Therefore, I have the new calling plan. Okay. So again, statements 1 and 2 would be the premises, and statement 3 would be the conclusion. However, note that even if the premises are true, the conclusion does not follow from the premises, right? So even if it's true that if you have the new calling plan, then you can text your friends, and even if it's true that you can text your friends, that doesn't mean you have the new calling plan, right? Just because you can text your friends for free, there may be other reasons for that, right? That don't require you to have the new calling plan. Because remember, having the new calling plan is sufficient to be able to text your friends for free, but it's not necessary. It's not necessary, okay? Or at least we don't know that it's necessary. We weren't told that in the premises, okay? So, so the person may not have the new calling plan. They may have qualified for free texting in some other way. All right. So what we're going to do in this section is we're going to use truth tables to determine if an argument's validity. And here's how we do that. First, we make a truth table with separate columns for each premise and the conclusion. Okay. Then we're going to examine only the lines in the table in which all of the premises are true. Okay. And then, if the conclusion is also true for all of the lines you considered in step 2, then the argument is valid. If the conclusion is false for even one of the lines considered in step 2, then the argument is invalid. So we'll do this with the arguments that we've already seen. Okay, so for example, here's a truth table for that first argument. So let's let P represent the statement Mahala passed the bar exam. So P for passed, right? And let Q represent the statement she's qualified to practice law. So Q for qualified. So if you pass, then you're qualified, right? So we would write this statement up here symbolically as follows. If P, and I just realized I have a typo there, passed. Okay, if P, then Q, right? So if P, then Q, P, right? And then therefore Q, right? And that's what those 3 dots mean, right? That triangular little 3 dot thing means therefore. So we have if P, then Q, P, therefore Q. Now here's the truth table for this argument. So you have to make a truth table, basically you have to make a truth table for each premise as well as for the conclusion. In this case, all of them have the variables p and q. So we have two variables, p and q, and we're going to do the same thing that we've been doing. If you haven't watched the previous two lectures, go back and watch lectures 5 and 6 before you watch this one. Okay? So now we look at the premises, right? Or premises. So for premise 1, if p then q. Remember that a conditional is true as long as well, maybe a better way to say it is that a conditional is false whenever you have a true p but then a false q, right? So this is going to be false. The rest of them are true. Okay, so the premise is true in all other cases. Premise 2 is just p. Well, p is true, true, false, false. True, true, false, false. In fact, we didn't even necessarily need to rewrite premise 2, but I think it's easier to lay it out this way so that you see premise 1, premise 2. And now the conclusion is q. We have q over here. True, false, true, false. Okay. Now, we're only going to consider the rows where we have both premises that are true. So, both premises true. So, both of the premises are true in row 1. Here they're not both true, here they're not both true, and here they're not both true. So, the only row where both premises are true is row 1. And then the question is the conclusion also true? And the answer is yes, right? So these ones, these rows don't matter. Don't matter because both premises, or maybe I should say because it is not the case that both premises are true. Maybe I'll say because at least one premise, is false. Okay, and we only want to consider the cases where both premises are true. So these three rows don't matter because at least one premise is false. Okay, but in this row, both premises are true and the conclusion is also true. So both premises true and conclusion true. So the argument is valid. Okay? So that's how we determine the validity of an argument. Now in this case we only had one row to consider because the other three didn't matter. But in some cases you could have multiple rows that you can consider, right? Let's take a look at the next example, right? So it says, so now this is a truth table for the second argument. So remember the second argument, let's just review, right? The second argument was if I have the new calling plan, then I can text my friends for free. I can text my friends for free, therefore I have the new calling plan. Now we've already discussed the fact that this is not a valid argument, but let's write it symbolically and use a truth table to determine that same thing. So let's say that C is the statement I have a new calling plan, and let F be the statement I can text my friends for free. So we can write the argument on the previous page symbolically as follows. If I have a new calling plan, then I can text my friends for free. I can text my friends for free, therefore I have a new calling plan, right? That's the format of that argument. And it's not valid. And here's a truth table to help us show that that's not a valid argument. So again, we'll do true, true, false, false, true, false, true, false. Premise 1 says if C then F. Okay, that's only going to be false here. It's true everywhere else. Okay. Premise 2 is just F, so I'm just going to copy F down. And the conclusion is just C, so I'm going to copy C down. T, T, F, F. Okay, and remember now, I'm only going to take into account the rows where both premises are true. So that would be in this row, both premises, premise 1 and premise 2, they were both true. And in this row, both premises were true. Okay? This row doesn't really matter. And this row doesn't really matter. Because in those two rows you had at least one premise was false, so we don't even consider those. But in these two rows we have both premises true. Now notice that here the conclusion is also true, but here the conclusion is false. Right? So even when both premises are true, the conclusion could be false. So this argument is invalid. Okay? So that's how that works. So now let's do a couple more examples kind of from scratch. This first one says, determine whether the following arguments are valid. So this first one says, if the moon is made of cheese, then Taylor Swift has sold more than 100,000 digital albums. The moon is not made of cheese. Therefore, Taylor Swift has not sold more than 100,000 digital albums. By the way, the content of the arguments doesn't have to make sense. We're just interested in the format of the argument to see if the format itself is even valid. So let's see. So I'm going to say for the moon is made of cheese, let's call that statement C. C for cheese. Okay? And then Taylor Swift has sold more than 100,000 digital albums. We'll call that D. D for digital. Right? D for digital albums. So this first statement says, if the moon is made of cheese, then Taylor Swift has sold more than 100,000 digital albums. So if C, then D. Right? That's that first statement. The second statement says, the moon is not made of cheese. So in other words, that would be not C, right? So this is not C. All right, so this first one is if C, then D. The second one is not C. And then the conclusion is Taylor Swift has not sold more than 100,000 digital albums. So it's not D is the conclusion. Okay. But it looks like we just have those two variables, C and D. So let's make our truth table. Oh, I should have left myself a little more space above that so that I could write out premise 1 and premise 2. But premise 1 is if C, then D. So this is premise 1. Right? If C, then D. All right, so true, true, false, false, true, false, true, false. Now, if C, then D. It would be true here, false there, true here, true here. Okay, so there's premise 1. Premise 2 is not C. So for that, I'm going to look at the C column, and I'm going to switch the truth values. So it's going to be false, false, true, true. And then finally, we get our conclusion. The conclusion is not D. So for that, I'm going to look at the D column, and I'm going to switch the truth values. So false, true, false, true. Now again, I only care about the rows where both premises are true. So I don't care about this row because premise 2 is false. And I don't care about this row because both premises are false. But I do care about this row because both premises are true, right? They're both true. And I do care about this row because both premises are true. And then notice that even when I have two true premises, I sometimes end up with a false conclusion anyway. And that means that this statement is invalid. Right? It's invalid because of this guy right here. Okay? Okay, let's do another one. So part B says, if you buy the more expensive Hulu plan, then you can watch TV commercial free. I think there should be a hyphen there. Commercial free. Okay, so if you buy the more expensive Hulu plan, then you can watch TV commercial free. You cannot watch TV commercial free. Therefore, you did not buy the more expensive Hulu plan. So I'm going to say if you buy the more expensive Hulu plan, so I'm going to call that B, then you can watch TV commercial free. I'm going to say F. So B for buy, F for free. So the first statement would be, if you buy the more expensive plan, then you can watch TV commercial free. The second statement says you cannot watch TV commercial free. So not F. And the conclusion is you did not buy the more expensive Hulu plan. So not B. Let's see if that's a valid argument. Okay. So again, just two variables, B and F. Okay, true, true, false, false, true, false, true, false. Okay, the first premise, so premise 1, is if B, then F. Okay, so for the conditional, we're going to have true, false, true, true. Okay, premise 2 is not F. So I'm going to look at the F column and switch the truth values. False, true, false, true. And then the conclusion is not B. So I'm going to switch the truth values. F, F, T, T. Okay, now I'm only concerned about the rows where both premises are true, so I don't care about this one because premise 2 is false. I don't care about this one because premise 1 is false. I don't care about this one because premise 2 is false. But I do care about this last one because premise 1 and premise 2 are both true. And notice that the conclusion is also true, right? So this statement or it's not statement, but argument. This argument. And that goes for the previous one too. Instead of statement, I should have said argument. Okay, this argument is valid. Right? It's valid because whenever you have two true premises, you end up with a true conclusion. And that makes for a true argument. That makes for a valid argument. Okay? Again, the content of the argument might be nonsensical, but at least the format of the argument is valid. Okay? Very good. So hopefully that makes some sense to you. Now, in order to avoid having to make truth tables every single time, we have some shortcuts that we can take. So here are some valid arguments that you can recognize without having to make truth tables. Although it might be a good idea for you to make truth tables to convince yourself that these are valid arguments. It also makes some intuitive sense as well, right? So this first one, and this is one that we've seen a lot, this is called the law of detachment. And the format for the law of detachment says, if P then Q, P, therefore Q. Right? And that's a valid argument. That was like example, the very first example we saw on the first page, right? This one where we were talking about if Mahala passed the bar exam, then she's qualified to practice law. Mahala passed the bar exam, therefore she's qualified to practice law, right? That's the law of detachment. The law of contraposition. Just like the name implies, you're going to be using kind of the contrapositive, right? You're going to say, the first premise is if P then Q. Then the second statement is going to be not Q, right? Well, if P implies that Q happens, but Q didn't happen, then that means P must not have happened either, right? So that's a valid argument. If P then Q, not Q, therefore not P. That was like the part B here. This was the law of contraposition. B, if B then F, not F, therefore not B, right? It's a valid argument. Okay? The law of syllogism. This is one that we haven't seen yet, but we will, right? Law of syllogism says if P then Q, if Q then R, therefore if P then R, right? So in other words, P implies Q and Q implies R. Therefore, P must imply R, right? So that's the law of syllogism. So that's a valid argument. And then disjunctive syllogism is another valid one. It says P or Q, not P, therefore Q, right? So if P or Q is true, and you know that P isn't true, then that must mean Q is true, right? Because one of these things, at least one of them has to be true. So if you know that P isn't true, then Q is, right? So that's a valid argument. And again, you're welcome to make truth tables for these two. We've already done truth tables for these two, right? But you're welcome to make truth tables for these two to convince yourself that these are in fact valid arguments. Here are some invalid arguments. So we have the fallacy of the converse. It says if P then Q, Q therefore P. And you can see why it's the fallacy of the converse, because it's like you're trying to use the converse to prove the original, and it doesn't work, right? Just because Q happened doesn't mean that P necessarily had to happen, right? So that's the fallacy of the converse. That would be like this second example here that we saw. If I have a new calling plan, then I can text my friends for free. I can text my friends for free, therefore I have the new calling plan, right? If P then Q, Q therefore P. It's invalid. And we showed that it's invalid. The other one is the fallacy of the inverse, right? So if P then Q, not P, therefore not Q. Again, just like the name implies, right? The inverse. It's like you're trying to use the inverse to prove the original, but it doesn't work because the original and the inverse are not logically equivalent. So this is a fallacy. And I think that was, did we do that one? Did we do something like that one? Yeah, that was like example 1A. This is the fallacy of the converse, right? We had if C then D, not C, therefore not D. And you can see that that's invalid. That kind of argument's invalid. Two true premises could lead to a false conclusion. Okay, so these two are fallacious. These are valid. These are invalid. Okay? So for this next set of examples, let's just identify the form of each argument, and then without making a truth table, let's see if we can state whether it's valid or invalid. Okay? Just by noticing what kind of form it has. Okay, so it says, if you want to improve your cardiovascular fitness, then take up cross-country skiing. So if you want to improve your cardiovascular fitness, then take up cross-country skiing. So I'm going to call that first statement, you want to improve your cardiovascular fitness, I'm going to call that F for fitness. And then you take up cross-country skiing, I'm going to call that S for skiing. So this first statement says, if F, then S. Okay. The second premise is you take up cross-country skiing. So that's S. And then the conclusion is, therefore, you want to improve your cardiovascular fitness. So you want to improve your cardiovascular fitness was the statement F. So this argument has the form, if F, then S. S, therefore F. That's the fallacy of the converse, right? Right? It's the fallacy of the converse. So this argument is invalid. It's the fallacy of the converse. Right, so it says identify the form of each argument. The form of this argument is the fallacy of the converse. And then state whether it's valid or invalid. It's invalid, right? It's the fallacy of the converse. Okay, part B. If you sleep through your morning math class, then you will be well rested. I love this example. Okay, if you sleep through your morning math class, then you will be well rested. So I'm going to call, if you sleep, I'm going to call that S for sleep. So if you sleep through your morning math class, then you'll be well rested. I'm going to call that R. So if you sleep, then you'll be well rested. Second statement, if you are well rested, then you will do well on your math test. So for well rested, that was R, right? That was the statement R. Then you will do well on your math test. So you will do well on your math test. I'm going to call that T for test. So this one says, if R, then T, right? If you're well rested, you'll do well on your test. Okay? Then the conclusion is, therefore, if you sleep through your morning math class, then you will do well on your math test. Right? So if you sleep through your morning math class, then you will do well on your test. Right? So the form of the argument is, if S, then R, if R, then T, therefore, if S, then T. That's called the law of syllogism, right? That's the law of syllogism here. And it's a valid argument, right? This argument is valid. Right? It's valid. It's the law of syllogism. Okay, so again, now's as good a time as ever to point out that the actual content of the argument doesn't have to make sense, right? There are obviously problems with this argument, but the problems with this argument are not the format of the argument, because it's in a valid format. The problem with this argument is the content of the argument. So anyway, so this doesn't mean that it's a good argument. It just means that it's valid. It's in a valid format, right? It's the law of syllogism. Okay. One last example, okay? So we can also use truth tables to analyze more complex arguments, and I just wanted to give you an example of something where you have more than two variables, because the only arguments that we've analyzed with truth tables so far have had only two variables, and so I wanted to show you one that has more than that. So let's determine whether this argument is valid or invalid. It says, if we balance the budget or reduce taxes, then there will be more money available to fight pollution. So, okay, so I'm going to say if we balance the budget, I'm going to call that B for budget, or maybe B for balance, whatever. If we reduce taxes, I'm going to call that R for reduce taxes. So we have if B or R. Okay, so if B or R, then there will be more money available to fight pollution. There will be more money available to fight pollution. I'm going to call that F. F for fight. So that first statement has the form if B or R, then F. Right? If B or R, then F. Okay, that's the format of that first premise. Second premise says, if we do not balance the budget, then we will not reduce taxes. And maybe I'll number these. This is premise 1, premise 2, premise 3. And then this is our conclusion, right? But premise 2, if we do not balance the budget, then we will not reduce taxes. Well, balancing the budget, we called that B. So we do not balance the budget would be not B. And it says, if we do not balance the budget, then we will not reduce taxes. Reduce taxes was R, so we will not reduce taxes would be not R. Okay, so here's our first premise. Here's our second premise. And then our third premise, we will not reduce taxes. Okay, we will not reduce taxes. Reduce taxes was R, so we will not reduce taxes would be not R. Okay, so there's the third premise. And now for the conclusion. It says, therefore, there will be more money to fight pollution. There will be more money to fight pollution. We called that F. So the conclusion is F. Okay, so now that we've done that, we're ready to make our truth table. So we've got three variables, B, R, and F. That means I'm going to have 2 to the third power number of rows. That's 8 rows. So T, 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 F, 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 F. T, T, F, F, T, T, F, F, T, F, T, F, T, F, T, F. Okay. Now, for the first premise, this is the first premise, B or R. If B or R, then F. In order to figure that out, in order to have a truth table for that premise, we first need to figure out what B or R would be. So first I'm going to do B or R. And notice that B or R all by itself is not any of our premises, right? But we do need to figure out what it is in order to figure out what our premises are. So B or R. So I'm looking at B and R, and I just need for one of them to be true in order for B or R to be true. So here we're going to have true, 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 false, and false. Okay, so there's B or R. And now we can do premise 1. Premise 1 says, if B or R, then F. And this is premise 1. Okay, so let's see. So I'm going to be comparing this column and this column. Okay. So if true, then true. That's true. If true, then false. That's false. If true, then true. If true, then false. If true, then true. If true, then false. If false, then true. If false, then false. Okay, so there's premise 1. Okay, and if you want to make your work easier, remember that when we're evaluating arguments, we don't even look at the ones where you have a false premise. And here we can automatically get rid of like 3 of our rows because right off the bat we have a false premise with premise 1 on those 3 rows. So I'm not even going to worry about those ones in my next calculations. Okay, you can fill them out if you want, but you don't really need to. For the next premise, I need to know what not B is, and I need to know what not R is. So I'm going to make a couple rows for those. And then I'll be able to do premise 2, which is not B. If not B, then not R. So this is premise 2. Okay, so not B. So I'm going to look at B. I'm going to switch all of the truth values. So it's going to be false, 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 and then true, 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 true. For R, I'm going to do the same thing. False, false, true, true, false, false, true, true. And now I can evaluate premise 2. Okay, so not B, if not B, then not R. So if false, then false. That's true under a conditional. If false, then false. If false, then true. If false, then true. If true, then false. That's where it fails. If true, then true. That works. Okay, premise 2. For premise 3, premise 3 is just not R. Oh, which actually I've already done already, right? So this is actually premise 3. Oh, see, and I said I wouldn't do the rest of the rows, but I got carried away and I did them anyway. Anyway, so this is premise 3. So that's premise 3. So then the only thing I need is the conclusion. The conclusion is F. And I know I've already written the conclusion over here, but I'm going to copy it down over here again just to make it easier for me. So it's TF, 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 TF. Okay, now again, I'm going to disregard any of the rows where I have a false premise. So here I have a true premise, a false premise. So maybe it'll help to circle the columns that I'm looking at. This one, and this one. Here I have a false premise, so I don't care about that. Here I have a couple of false premises, so I don't care about that. Here I have all 3 are true, so I do care about this one. Here I have a false premise. Here I have a couple of false premises. Here I've got all 3 false premises. Here I've got 3 true premises, and here I've got 3 true premises. Ah, dang it! It was almost a valid argument, but look at that. Look at that, right? So I've got true, 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 but false, right? Here I have true, 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 and true. And here I have true, 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 and true. You don't have to go back and circle stuff in your truth tables. I'm just trying to make it more clear for you to see what the problem is, right? So here we have 3 true premises and a true conclusion. Here we have 3 true premises and a true conclusion. But here we have 3 true premises and a false conclusion. So that means that this argument is invalid, right? Okay, and that's how this works. So that's that. Okay, you're welcome to go back and try to make sense of that in words if you'd like. But that's how we would do it symbolically with truth tables. So we can tell this argument is invalid. So even if the content is good, it's still a bad argument. Okay, and that'll do it for lecture 7.